Hello, I am Bonmayuri from Assam Don Bosco University. Today I am going to teach you all a very important topic, that is semiconductors. When you hear the word semiconductors, what do you think about? Semiconductors have properties in between insulators and conductors. Insulators do not conduct electricity at all. They have a very high resistance to the flow of electricity. Insulators consist of non-metals such as sulfur, iodine, etc., which do not conduct electricity at all. Conductors, on the other hand, such as metals, conduct electricity. Example: zinc, copper, aluminium are excellent conductor of electricity. Semiconductors are basically metalloids and they do not conduct electricity as conductors. However, they do conduct some amount of electricity. Some good examples of naturally current semiconductors are silicon and germanium. They are also known as metalloids. So basically, semiconductors are of two types: intrinsic semiconductors and extrinsic semiconductors. Their basic difference lies in their purity. In case of intrinsic semiconductors, they are known as pure semiconductors, or we can say that they are made up of pure tetravalent atoms. But in case of extrinsic semiconductors, they are known as impure semiconductors, as we add impurity to it. And extrinsic semiconductors are again divided into two types: N-type semiconductors and P-type semiconductors. We will understand the whole concept in terms of holes and free electrons. At first, we will talk about intrinsic semiconductor. For intrinsic semiconductor, we will consider a crystal structure. As we know, semiconductors are made up of tetravalent atoms. However, tetravalent atom crystal is called semiconductor. In tetravalent atom, valence shell consists of 4 electrons, as we can see in the diagram. A tetravalent atom makes covalent bond with the 4 nearby atoms. With the 4 atoms, a tetravalent atom shares one atom each. After that, implying with Pauli's exclusion principle, it becomes very stable. Now, when some amount of heat is provided due to thermal agitation, one of the electron in the valence band gets high amount of energy and goes into the conduction band, and thus forming a free electron. This free electron will help in conducting current. In this process, the atom's valence band falls short of one electron, and that empty place is known as a hole. This hole and the free electron are called charge carriers because they both help in the flow of current. The holes trap the free electrons in order to maintain the flow of current. This sample is purely made up of tetravalent atoms, example silicon and germanium. Generally, the conductivity is very low, so to increase the conductivity, we add impurities to intrinsic semiconductors. This process of adding impurity to a pure tetravalent substance is known as doping. Now, let us consider the case of extrinsic semiconductor. In the figure, you can see we have considered a crystal structure of tetravalent atoms. Here, when we add trivalent, whose valency is 3, or pentavalent atom, whose valency is 5, it becomes an extrinsic semiconductor. Here in this diagram, you can see a trivalent atom consists of 3 atoms of its own. In a structure of tetravalent atoms, when we add trivalent atoms, there are only 3 electrons, that is, its valency is 3. Thus, upon adding trivalent atom, it creates a natural hole. In this place, you can see it creates a natural hole. It means here it can accept an atom naturally by Pauli's exclusion principle. Thus, to get a stable configuration, it will demand 8 electrons in its valency. Thus, it leads to the formation of a hole. For this, we don't have to provide heat, but it occurs naturally. Since it occurs naturally, we can term it as P-type or positive type semiconductor, as the holes can take the negatively charged electrons. Similarly, when we add pentavalent impurity in a pure semiconductor, it leads to the formation of a free electron. Here you can see in this diagram, it leads to the formation of a free electron. As we know, in case of pentavalent atom, it has a valency of 5. So when we add pentavalent atom, it's it's 4 electron along with the 4 electrons that is shared from the neighbors. It makes up of 8 electrons in its valence shell. The extra 1 electron is so loosely bound and is lead to the formation of a free electron, and for this we don't have to provide heat, but it occurs naturally. When we add pentavalent atoms as impurity, the semiconductor is known as N-type or negative type semiconductor, as there is a free electron. The impurities that are added is added in the ratio as small as 1:10 to the power 6. When we make p-type semiconductor, we strictly have to add trivalent atoms as impurities, and similarly while making n-type semiconductor, we strictly have to add pentavalent atoms only.